So welcome everyone, and thank you for joining us at the Wireless Power Industry's first Joint Industry Thought Leadership webinar series, hosted by WAWT, that is Wired and Wireless Technologies. Today's topic will cover distance wireless charging technology. So before we start, and while we wait for everyone to join, let me just briefly introduce myself. My name is Kat, and I am the event coordinator of this webinar. So in order to participate in this webinar successfully, please make sure that your audio is connected to the platform. You can do so by checking at the bottom of your Zoom screen if you are connected. If you are experiencing any audio issues throughout the webinar, you may try connecting with your headphones or just let me know in the chat box by messaging the host directly, which is me, and I will try to assist you as soon as possible. Also, please note this webinar is being recorded for any of the registered participants who are not able to attend today, and you will also receive a copy of the recording link after the webinar. And finally, the webinar today will include 6 presentations from each of our esteemed thought leaders, a couple of interactive audience polls, a panel discussion, and an audience Q&A session at the end. So throughout the webinar and during the audience Q&A session, please type your questions in the Q&A window at the bottom of your Zoom screen. That is through the Q&A icon at the bottom. And we will try to answer as many as possible. Please make sure that you do not submit your questions in the chat window, as they will not be addressed. Now, without any further ado, I will introduce Mr. Dinesh Kithany, the founder and chief analyst of Wired and Wireless Technology and the organizer of today's webinar. So, Mr. Kithany, over to you.
Thank you, Kat, for your brief introduction to the webinar and nice housekeeping lessons, rules and regulations for us. I would like to firstly say thank you each and every panelist for taking this opportunity and helping me host this webinar, which, as you know, is the wireless power industry's first industry webinar, joint industry body webinar, where one of the key participants from the company, from the industries are part of it. So the topic, as you know, is distance wireless charging technology, a reality. A very, very important topic, a very, very emerging technology where I'm sure everybody wants to know what the status is on. And just like Kat mentioned, it's a very power-packed webinar, 90 minutes. We may have to rush for some sessions, I hope not. But let's try to keep the time. And without wasting much time, I would then say thank you each and every audiences for participating. I would say good morning, good evening, good afternoon, because I know it's across the globe that people are attending that, and different profile of people there. So really appreciate your time. I hope you will be able to sit for the entire 90 minutes, and I assure you, you will only gain a lot of informative and insightful presentation. And surely you'll have a lot of questions now, or even you can send us the questions after this webinar. Send it to me, I'll forward to the right panelists here, our esteemed speakers. And thanking all the speakers, what I do, I'll not talk about each of them. Let them say in 30 seconds, I would tell them about yourself and why they're here for. So I will start first with Sanjay Gupta. Sanjay, please introduce yourself.
Thank you, Dinesh. So I'm Sanjay, and I'm a tech entrepreneur who has a passion for commercializing new technology, have a track record of commercializing new tech in the wireless space for about 25 years. And currently, I'm the chairman and the president of the board at AirFuel Alliance, an industry organization that is working on wireless power standards.
Perfect. Thank you very much, Sanjay. Thanks for the introduction. Let me now ask Ashish. Ashish, can you give your introduction, please?
Hi, my name is Ashish. I'm the CEO of Transify. We are about less than 4 years old wireless power transfer company for far field. At the moment, our core focus is basically wireless power transfer within the IoT space and being able to reduce cost of deployment and integration of IoT, and pretty much creating a scalable future for power distribution for sensors. That's
interesting. Thanks, Ashish. Thanks, Ashish. I think I'm sure you have a lot more to say in your presentation, but really good. Over to you, Neeraj, for your brief introduction.
Right, thanks, Dinesh, and happy to be part of such a great panel. I'm Neeraj. I'm responsible for customer and products at Energous. For 25 years of experience in the semiconductor industry, have taken 4 generations of new technologies to market, and happy to be here.
Excellent. Thank you, Neeraj, for your time. And over to you, Hatim.
Thank you, Dinesh, for organizing this event. My name is Hatem Zain. I'm the founder, CTO, and president of OSIA. I'm really a physicist and technologist trying to bring the world to the 21st century. We've been stuck too much in the 20th century and or the 19th century in some cases. And I'm glad to be here, glad to be working with this group on popularizing wireless power.
Perfect. Thank you very much. Ori, you are next.
Hello, Dinesh. Happy to be here. I'm Ori, one of the founders at YCharge, today the Chief Business Officer in charge of all the customer activities. Before that, I'm a technologist by nature. I did high-end technology for the last 20 years. And this is going to be the very most interesting one.
Well said. Yes, very much. We are all looking for this interesting and insightful webinar. So without spending more time, I would like to hand over the podium to Sanjay Gupta, who will be our first presenter. Being obviously representing an industry body, it's a good start for our presentation. Over to you, Sanjay.
Thank you, Dinesh. Great, my pleasure to be here. And let's get started. So I think it's a wonderful and exciting time to be in the wireless power industry. We've all experienced wireless power, whether it's charging our toothbrushes or our phones. And it's like the first generation technology. We are all familiar with wireless communications, and we've seen cellular technology go through, from analog, and now we're in the 5th generation. Wireless power is in its early stages. We're in the 1st generation technology, which is inductive. And even though the technology is great, the consumers are looking for more. And what they're looking for is an ability to charge multiple devices at their full wired speeds, freedom from having to place these devices literally at a point, right? So they would much rather have, the wireless is all about freedom. They want the freedom to put their devices and have them charge wherever they are and free them from the battery anxiety at the end, which we've all experienced. So what Airfuel Alliance is working on are really 2 different technologies targeted for 2 very distinct set of applications. The first one, a magnetic resonance technology, which I like to say enables a 2-dimensional charging experience, creating surfaces on which you can put multiple devices with different amounts of power that can charge. And RF technology, which is really wireless power at a distance, which is what we will focus on today, is about delivering power in a 3-dimensional space, the ability to charge devices in their natural places of use. So let's dig into what this means, right? What is charging at a difference, or what charging or wireless power using RF means? It really is all about spatial freedom, the ability to charge devices in a 3-dimensional space. So imagine a retail store shelf display that we are starting to see now, and the ability to deliver power to them, even though it may be a little bit small, so that they don't need batteries and they can be refreshed as often as you would like them to be. Or think of the IoT sensors at your home. Think about your wearables. All of these devices require small amounts of power, and how are you going to deliver them power and not have to worry about conscious thought of charging these devices? And of course, you have to make sure that the technology is safe, low cost, and I think the most important aspect of the RF-based wireless power is to be able to build devices that really are free of batteries in them, right? So we don't have to even need batteries. You don't have to worry about changing them at all. So let's really talk about what is capable today with the RF-based technology. It's ideally suited to deliver small amounts of power, as I said, typically less than 1 watt. And the limitation of power comes from not what the technology can deliver. However, it is limited by the safety and regulatory considerations. And we can talk a little bit more about it. It also depends on the frequencies that you're using, but typically RF-based power is great for delivering less than 1 watt of power. And trust me, there are billions and billions of these devices. This is a fairly big market that fit into the space. The ability to charge multiple devices, right? If it is a one-to-one experience, it's really not wireless in my view. And the RF-based wireless power allows you to do this. And in AirFuel, we use the 900 megahertz ISM band. However, the technology works at other frequency bands as well. And we are continuing to investigate those as well. So before I kind of hand it over, it's probably good to just talk about AirFuel Alliance a little bit, in case you're not familiar with it. AirFuel Alliance, at the end, as I said before, is a global coalition of companies who are all committed and are passionate about wireless power and enabling what we all so desperately want to achieve, which is a world which is free of wires. We've gotten rid of the last cords in our lives. And AirFuel Alliance delivers on that mission. The most important thing that we do is to write the technology standards so that we can have interoperability in the market. Standards are essential to allowing the membership to grow at the end, right? Anything wireless, the market cannot grow and expand because of, are the devices going to come first? Are the infrastructure going to come first? And everybody looks at each other and there is no investment. Standards is the glue that helps all of it come together. And that's the most important activity that AirFuel Alliance does, is to write standards that provide interoperability in the market. And we make all of this happen by having a diverse membership, a global membership of the industry's who's who, from all across the different aspects of the wireless power value chain, working together under one umbrella, driven by the same mission. I'm not going to read all the names here, but we have literally, as I said, the who's who and all aspects of the value chain are represented. And the last thing that I wanted to emphasize, as I said, is, AirFuel Alliance is an open industry organization. We welcome every company who has a passion in wireless power to come work with us. And we have a governance structure that allows and facilitates that. So, and what I mean is we have an IPR policy that is based on reasonable and non-discriminatory. Technical specifications are based on member contributions. So, even me as the chairman have no influence on actually what the organization does. Each member of AirFuel Alliance has an opportunity to contribute, provide their technical inputs, and the contributions are discussed at the working group levels and decisions are made. And the AirFuel Alliance board merely makes sure that the process has been followed rather than providing technical input. So really, we are an open standards organization. Every company is welcome to join. And finally, we talked about interoperability, and we have a certification program to make sure that we can certify products are interoperable. And the certification program is administered by independent test labs. So nobody in AirFuel Alliance is actually aware of the products that are moving through the certification process, or we have any influence on which products pass certification or they don't. So anyway, so I think I'm going to probably stop here now. And I'm sure there's a lot of questions, so I'm looking forward to answering those. So Dinesh,
sure.
Back to you.
Sure. Thank you very much, Sanjay. Yes, a very informative thing. I'm sure still there are many questions. You have already answered, you clarified on a few issues as well. But I'll come back to that on that. So let's then next go to our next speaker here, Ashish Mehta. Ashish, over to you for your presentation. All the best.
Thank you so much. Thank you so much for introducing us and also being able to bring us be part of this panel of speakers. Let me share my slides here. Hi, my name is Ashish. I'm the CEO of Transify. So essentially, Transify is a company that was born out of two co-founders, Dr. Reza and myself, Ashish. We started the company in a perspective of being able to have this vision of providing access to power to anyone, anywhere, anytime. That's a vision that we had as a company, to be able to see how we can change the world in terms of power connectivity, in terms of being able to access power in a much simpler and easier way. But essentially, the mission of the company right now is to create long-range, safe, and efficient wireless power network technology using radio frequency perspective. Now, obviously, there's a lot you can get to in terms of being to wireless power. We decided to focus on is being able to really kind of look into this beachhead application of wireless power, long range within industrial applications. Now, why we saw this as a great place to start is because power is pretty much a backbone for almost every industrial revolution. The first is all about steam engines. The second is all about AC distribution. Third is all about inverter control systems. And now we are in the fourth industrial revolution where we're thinking about digitization, thinking about how to get to autonomy. For autonomy to happen, you need to turn this physical space around us into a whole digital economy. And to do that, you need mass sensor deployments. You need to be able to figure out ways to scale your sensors. And you can't rely on cable infrastructure or batteries for that matter. So that's where wireless power transfer comes into play in a big way in terms of applications. Now, what I'm going to talk about more is about how applications kind of lead the need and the value of wireless power transfer, and also at the same time that it's already being deployed, is what we've been doing right now as a company. So one of the big things in which you start realizing when you look into industrial IoT is that if you look into cost structures, this is ridiculous. I mean, if you look into how average industrial IoT, then most of it's all cost goes into cable infrastructure, which is basically just labor. And the rest of the intelligent part, which is really sensors, PLCs, software, electrical design, all the intelligent stuff is really less than that, less than 40%. And what's interesting is that cable infrastructure is always going to increase. Now, battery technology is supposed to take this over and be able to disrupt and create this trillion deployments of IoT out there, but it never really happened because it's just something where you realize that, to implement batteries, it kind of introduces new sort of manual maintenance, which kind of goes against autonomy. So that's the reason why wireless power technology is so important as well, is to be able to see how we can, distribute power without the need for the cost of cabling, but also need for replacing batteries overall. And that's where wireless power transfer comes into play. We can disrupt this 62%, remove a huge 80% chunk of it, make it a lot more scalable. At the same time, retain the same data quality that you're getting in cabling infrastructure. And that's super exciting as we move forward with wireless power in the future, being able to distribute power and have a network of power distribution down the road for IoT in this perspective. Now, this is not just theoretical. This is something that we've built, and it's something which has been deployed. We've deployed the system in multiple MNCs out there, and I can definitely name quite a few of the industrial automation companies that have been buying our hardware. But essentially, we have a gateway, we have a sense node. What's cool about this gateway, it does both power and data together. Essentially, releasing beamforms of power, pretty much power signals towards these sense nodes, which have multiple sensors on board, 6 sensors altogether: temperature, humidity, pressure, vibration, 3-axis acceleration, acoustic, TVOC, kind of covering a multitude of applications overall at a 25-meter range. And at the same time, the power kind of gets harvested by these sense nodes, powers up the sensors on board, receives the data, and then sends the data back to the gateway, which pretty much publishes it to any cloud system out there. And we're publishing quite a few places from the E-Times, Economist, National Geographic, Austrian magazines, and so on. We have 1 patent granted and 2 patents in progress, which is super exciting. And it's, in a commercially, this is like one of the first commercial applications that's already running, has been deployed. It's a turnkey solution. And it's exciting, right? What's interesting about wireless power has always been about the deployability, is about the commercialization aspect. We have these systems out there. It's already been deployed. It's something where we're looking at long-range wireless power transfer as reality, and it's already having ROI within the industrial IoT sector. Now, what we've developed, or as a technology point of view, is we focus a lot of our time in being able to make this a commercial application, which is basically involving IP modules to make it easy to deploy and simplify the whole process of being able to auto detect multiple devices out there, making sure you understand exactly the reflections. So one thing about wireless power transfer is that beamforming is something which is super important to be able to ensure that we have the right density of radio frequency to each and every device, because we're limited to the amount of power you can output, right? So with that perspective, we want to make sure that we can time share these beamforms. Now, obviously, with with an omnidirectional antenna, with a system that has 360 degrees worth of freedom of beaming, you have billions of options to be able to beam. Now, with what we've developed, what we focused on is being able to kind of create a calibration system that's automated, that's simplified, that allows easy and simple within a few seconds, the ability to be able to find the right path to each and every device, up to 32 devices altogether, where we are optimizing the beams in the direction, taking into account in terms of distance, taking into account reflections, taking into account any interferences, to be able to optimize a time sharing methodology to different types of sense nodes out there, or receiving devices in this case. So we not only optimize the calibration of it and the power sharing, we also optimize the actual power, the RF power system in terms of waveform, and also the data integration to accommodate multiple devices out there. And it's something which we've been deploying quite a bit, and it's exciting because it's really nice to be able to see all these things deployed in a very robust, reliable manner. Now, what we've developed is not just about IoT, right? In the end of the day, it's all about being able to use something that's really robust, reliable, high quality. I mean, these things have already been tested by companies like Schneider Electric, Asbill, Yokogawa, all these big companies out there, to be able to focus on reliability and quality. So that's there. Now it's all about just trying to see how we can use this as reference architecture for multiple applications out there in the future. And that's what's exciting as well. Being able to have something that's been tested and tried as a reference system to be able to make sure that we can deploy it for any application out there and ensure that you have robustness, reliability, and high quality power. Now, the applications which we have focused on mostly have been smart buildings and manufacturing, which is quite exciting. So within the manufacturing sector, a lot of it initially was all condition monitoring, vibration monitoring. Within the smart buildings, all just general environmental sensing, being able to save energy within a building and be able to deploy sensors, which is around 5,000 sensors per building on average, and be able to remove the cost of cabling, reduce the time for deployment. Same with also manufacturing at the same time. We've worked with multiple partners from Schneider Electric, Yokogawa, Bosch Rexroth, and also we have other partners that we're going to work with soon as well down the road as well. So it's quite exciting as we move forward. But not only that, we have an architecture which we are working with different companies, which we can talk about right now, but essentially to customize applications that are ideal for that specific product out there. Now, here's some deployments I've done a long time ago. This is one of our deployments with our version 1 of our system, where we have this really large LCD-like panel system here, which is a phase array antenna in Schneider Electric's office. Now, in Schneider Electric, what they're focused on is being able to do 5,000 sensors within a smart building. In fact, this smart building that we deployed in, which is Schneider Electric's building in Singapore, has about 5,000 sensors or more within that building itself. Now, for them, it was just super important to be able to remove cabling infrastructure. That cost is just ridiculous. So we were able to reduce that cabling cost by 50%, which is huge. And it's something which I think no smart building or no company out there can actually ignore. And something which I think in general, when it comes to wireless power transfer, it is a system that's already been deployed. It's running for about 20 months now. In fact, by the end of this year, it'll be a 2-year mark in which we've been running without any downtime whatsoever. It's collecting data from vending machines out there and pushing it to the BMS system. It's just exciting to see these things all in action, which is actually quite cool. This is another one which is in a manufacturing site where we are even powering up gantry systems which are moving. So this gantry is really exciting actually. We have a gantry system that's moving left and right, up and down, and the beamforms are tracking it constantly and being able to deliver power in a very, very robust and reliable manner. At the same time, powering up sensors on the gearbox manufacturing line 3, 4, and 5. And you can see G here. G is basically where our gateway is, which is a 16-channel wireless power network gateway. In fact, at the same time, we're also powering up a sensor node on a CNC routing system as well. So it's just so clear and exciting to be able to see these things robustly running at the same time and deployed. And I think one of the biggest things that we have I wanted to prove over here is that these things are running as per normal. It's not exactly something that's theoretical. This is already sold, is running, it's reliable, it's robust, and high quality. This is actually powering up sense nodes on a on what's it called, pumps on top of Yokogawa's building. Now Yokogawa already does vibration monitoring. They're fantastic about it. But when it comes to wireless vibration monitoring, to collect the same data that we have here, their vibration sensors that are using batteries will only last for about 6 months. Whereas when it comes to wireless power transfer, this is a lifetime of sensing, a lifetime as opposed to 6 months, where we are collecting X, Y, and Z data constantly with RMS, comparing it with ISO charts, producing FFT data up to the 20th harmonic. I mean, the amount of granular data you can get out of this is just immense. And these are obviously, now we've gone past the whole perspective of whether it's wireless power reliable, robust, or high quality. It's more about now the application, about what else can we do with wireless power transfer as we move along. And this is what we're looking at. Down the road, we're going to work with companies, simply OEE, which is operational effectiveness, whether a machine is wearing, and being able to map this information of machines all the way down to utilization, worker and technician sort of schedules, and be able to really understand exactly down to the point as to which machines have been effective and running in a super ideal manner. And it basically connects to the ROI directly. Now, if you look into the charts, I think the reason why I put this over here is really kind of really so wireless power transfer is about scalability, being able to put thousands of sensors out there. In fact, looking at 3,000 sensors where, you know, when it comes to cost structures and when it comes to being able to deploy these systems, you have options of batteries, you have cables, you have T5 wireless power network. Now, with cables, obviously the initial capex is quite high. It's expensive to install cabling. It's a lot of labor costs. With batteries, it's quite low, which is great. But when it comes to 4 million watts per sensor itself, you start realizing with batteries, you're having to actually spend a lot of money on actual battery changes, which is just batteries itself. When you include labor cost of changing those batteries, the downtime in changing those batteries, it even crosses the cabling much earlier within the 2 year sort of perspective. Whereas with wireless power, what's nice is that you are able to maintain the same operational expenditure with cables. I mean, it is a bit more inefficient, which is fine. But when it comes to milliwatt levels and so on, it's still super plausible over 20 or 30 years. And that's where it gets really exciting when you start talking about wireless power transfer in general and being able to be applicable and running out there. Now, with great power, obviously comes great responsibility. We have a great team that's running the system. We're just about 4 years old. In October, we'll be 4 years old as a company. We have systems already running. We've been selling. The revenue point of view is fantastic. Now it's all about being able to grow adoption, being able to create a norm of wireless power transfer in general. Dr. Reza and myself, we are both co-founders of Transify. I have about experience within National Instruments for about 8 years within industrials. Dr. Reza, his core experience is within the optimization wireless power transfer in his postdoc. Siddharth and Lionel is actually on the call right now. They both were brought on to focus on commercialization, taking ideas and making it manufacturable. And that's been exciting because we already got this product out there. It's already been manufactured and it's running.
Yeah, Ashish, I have to stop you.
When it comes to the advisory team, okay, sure, perfect. Actually, I'm pretty much in the end. We have a webinar coming up 22nd September. You can check it out. Here's a link, and these slides will be shared out. Thank you very much.
Perfect. No worries, Ashish. Thank you very much, and sorry to cut you here. But before taking time, Ashish, I think you raised a very interesting proposition presented for the industrial applications. I'm sure many others also have the same thing. And more interesting, looks like you have already set the ball rolling. And I think that is the message that we want to communicate to the industry, that yes, wireless power, distance wireless charge power is already in. We're already working on applications, and we have some examples already presented here. Before taking more time, over to you, Neeraj.
Hi, everyone. This is Neeraj. I'm just going to be talking about how Energis is taking advantage of this large opportunity. First of all, thanks Sanjay and Ashish for introducing the wireless power. We definitely believe that the market is really growing. A note on Energis. We are about 40 people company, started in 2014. Our model is fabless semi. We really believe in that wireless power is a great opportunity. There will be different frequencies, different application, but there is a need for a company which provides the component, not only in the transmitter side, on the receiver side. Today, we have multiple customer and partners who have announced their products. We have products in the market. We have multiple FCC and EU approval. We have reference design available for various verticals. Our claim to fame is first Part 18 at a distance approval, which was done in 2017. Today, we are approved to ship in 112 countries in EU and Japan. And then we are working on the China and Korea approval. So I think we all talk about the opportunity, right? And I'll just take you back to the communication that's where I come from. We believe at Energis, and I also strongly believe, no size is going to fit all. If you look into the wireless communication, which is a good way to look into this market, which is emerging now. There are different technologies for the LAN. There are different technology for wide area. There are different technology for personal area network and low power WAN now. Similarly, wireless power is in a very, very early stage where there will be different technology adopted for different applications. And we strongly believe in that. It's not possible the whole market opportunity or application can be addressed by one frequency, one way of doing things. And we see that, there are applications which will be addressed by, as Ashish said, from a beamforming perspective, industrial and other applications. And there are applications which will require a very low cost transmitter, which may not be beamforming. And I'm going to be talking about that in my presentation. So how do you really start to analyze a new market, right? We have been talking about this framework for some time. If you look into wireless power, it's not really new technology. It's there for 100 years. So now the question comes, why there is not much adoption? I think it's a very early stage, as I said. There are three forces happening on the solution space. Number one is basically the regulatory. The regulator is not going to allow you to transmit as much as power you want. You may be able to do that in a controlled environment, but not in a consumer environment. The second aspect of that is where the efficiency of the transmitter and receiver solutions are. And then the third aspect about is that what's the customer expectation? What are they ready to deploy? How do they see the benefit of deploying wireless power or other technologies? And when you start to put the path loss, and that's what is very important from the distance charging concept. When you start to put path loss at different frequency, and you start to combine these three forces, you need to start to look into from a perspective of, yes, there is a technology. We have seen many of them. There are so many demonstrations coming from the various companies, and that's a really good sign that there is interest in wireless power. But we believe the path to wireless power is going to be incremental. While negotiating the path loss challenges, while negotiating the regulatory efficiency of on the technology and the customer expectation. And we are on a path towards an incremental introduction of our customer products. We have divided or segmented the market into three areas: near field, which is about 0.5 centimeter, and then the midfield, which is up to 1 meter, a desktop kind of application, and then beyond 1 meter, 10 meters, 15 meters, and so on. We are seeing significant uptake in the far field market right now, and I think this panel has a lot of companies who are working in that area, and we definitely feel the market opportunity is definitely growing. It's going to be a question of, can we really provide a product from a cost standpoint, from a size standpoint, as well as from a performance standpoint? And when you start to look into it, semiconductor would be the heart of it. And that's where the value proposition Energis is bringing. We have significant portfolio on the transmitter and receiver side, and a lot more of our customers and partners are deploying that. So the distance is the key. I think for all of us, that's the real value proposition. And we need to keep on pushing that limit, how we can provide more power, more control, multiple charging, as Sanjay said. And I think that's where the real value proposition of RF power is going to come. Let me talk about active harvesting. That is a concept that we have launched early this year. What it means by that is, if you look into the harvesting, A lot of companies have proposed passive harvesting. That means they can just put an antenna in a 2.4 gig or 5 gig and harvest the power. What is the problem with that? First of all, the amount of power you're going to get is going to be very, very small. I came from the Wi-Fi world. I can tell you how small that power would be. The second is you cannot really control the amount of power you receive because you do not have the ownership or control over the transmitter network or the routers on all those networks. So you would need a definite transmitter technology or a charger technology that is providing you that reliability and the amount of power. And we believe the applications which are coming in the industrial, retail, they will require a low cost infrastructure. And that's why we believe the Power Hub technology that we launched early this year, or we have announced other technologies that will provide the right infrastructure at a low cost. Product has to be put in mind. Technology is just one part of it. I think we are at a point where the market is ready to take off, and it really depends whether we can agree to the product. That means the cost, size, and performance. And we have launched our solution. Our solution is ready at this point of time that you can evaluate this technology today. This is the harvesting kit. It's very small transmitter, different receiver. We have partnered with EPs, who's providing the key pieces of the receiver technology on the charging side. And you can actually evaluate this technology today. These are the different other vertical which we are addressing through a dedicated transmitter and receiver technology. You can actually evaluate the hearing aid, hearable, different kind of smart glasses and different IoT trackers, along with the distance solution that we have in the form of Power Hub, which is addressing the midfield market, and the energy harvesting solution, which is addressing the far field market. We really believe in ecosystem. I don't think so one company can do this. It's such a difficult problem. It's there for hundreds of years. So we really believe that we need to create an ecosystem of partners. We partner with Dialog as our exclusive chip partner. And then we have recently announced our partnership with EPs and Atmosic on the far field active harvesting side. And we have the partnership with battery companies and the other ESL companies, because unless you can provide a complete solution to the customer, they may not be able to adopt it. Any new technology, just saying that the technology exists, is not sufficient. We are responsible for providing the complete solution. And we believe that the system level solution has to be provided to different verticals. That means you will require the knowledge of these verticals, partnering with those companies, and making sure there is no burden on customer to figure out how to use this technology. Unless we do that, adoption of any new technology is not going to happen. These are some recent announcements. And as you can see, we are making very good progress on the regulatory. We just announced our EU approval for the Power Hub, which is a midfield technology. We have also announced a higher power 5.5 watt kit that can be applied for the harvesting application. We announced different partners for distance charging, and we continue to introduce new products. These are the 4 of the products that had been announced by early partner, and more products are in the pipeline. With that, I would like to hand it off back to Dinesh.
Thank you, Neeraj. Thank you very, very much. Some very interesting things to learn for the audience as well. I like the concept about what you said, no size fits all. And I guess everybody on this podium and also some of our partners who are attending the show understands that there's no size fits all. So there is an opportunity, big opportunity, which I'll talk about that. The opportunity is big enough and there's space for everybody to play a bigger role in that market. And second point, Neeraj, I liked about you is about the energy harvesting, active harvesting, which I know we have good propositions there. And interesting also was the developing kit available, which I guess the other players will also talk more on that. So again, without spending more time, over to you, Hatem. Hatem, you're mute.
Thank you. Thank you, Dinesh. As my slides come up, I'd like to talk to you about ASSIA and what we're doing in the industry. So ASSIA was founded to bring wireless power technology to the world. As we started working on this technology 13 years ago, we have patents older than that we realized that this is, people started talking about wireless charging. And turns out that we're not talking about wireless charging, we're talking about wireless power to devices that may or may not charge a device locally. So we'd like to talk about wireless power, which is the ability to deliver power to devices. And this means that now you can enable the IoT, the increased deployment of devices, starting from the lower energy consumption, lower power devices, growing up to bigger devices over time. The key to the market that we're addressing is that if you read all the literature about the IoT market and its growth, it is understood that there'll be about 500 billion devices, like Cisco estimates by 2030. Others estimate 1 trillion devices. Now, when you talk about that kind of number, actually having that many batteries is not even possible, since humanity doesn't build that many batteries a year. So most of the IoT devices that we will have in the future are going to be batteryless devices. That's where these devices are not in a charging scenario, they're in a power scenario. And for that to happen, these devices exist within their power transmitters domain. So they're existing somewhere where there's a power transmitter. So OSIA is focused on creating a real wireless power that can be deployed in the large numbers that we're talking about to achieve the abilities of what's needed. And in many ways, most of these devices should be at a distance, would be in motion, would be in non-line of sight, and you're powering multiple devices. You're running a system, as it were. So to do that, we have a technology we call COTA that has a real essence, which is that using COTA is basically feels like Wi-Fi. So you should be able to use the Wi-Fi scenarios of how we're used to using Wi-Fi. And the 5 things that really make it an experience like Wi-Fi are these 5, which is basically power at a distance. So we're talking about distances that can be 10 meters, less or more, depending on the design of the system, but that's really typically the same as Wi-Fi. The next one is that the power is controlled. So you're not sending power to every device or adjacent devices or whatever. You're in control. You're deciding to send power device A, then B, and give each one a certain amount of power, etc. The third one is that you should be able to power devices in motion. This is a challenge since you're focusing the energy to a device, but you need to keep that focus with the device as the device moves. This is one of the challenges that has made wireless power take such a long time to come to the market. Most of the applications are going to be, there's a lot of niche applications where devices don't move, but motion is not just the device itself. If the environment changes around it, for example, if the device that was deployed line of sight becomes a non-line of sight because someone stood in the way, you need to be able to adapt for that. And wireless power should work like Wi-Fi from a non-line of sight perspective. How many times have we tried to use Wi-Fi, looking for the Wi-Fi hub so that we can point our device to the Wi-Fi hub? That doesn't happen. And in wireless power deployments, if we want to see the 500 billion or 1 trillion devices, we will need non-line of sight to be happening. And the last one is that wireless power should be safe. Since I started the company 13 years ago, the question was like safety. Can you actually deliver wireless power at a distance safely? So addressing these 5 is really crucial for a wide broadband deployment of wireless power. So to do this, we actually do not use the traditional beamforming techniques of creating an RF beam from a transmitter to a receiver. That doesn't happen at OSIA. We don't have any technology in beamforming, not in software, not in hardware or operation of the system. So the way it works, we use a physics principle called time reversal. We start with the receiver device, sending out what we call a beacon signal that goes in all directions, and some of it lands on the transmitter. The transmitter is able to capture that signal as is and play it back to the device itself. You can see here in the top left diagram, the device sends out this beacon signal and it's received at the transmitter, and the transmitter responds to it, basically sending it back through every path it has arrived from. And that happens actually with no computation. So there are no software algorithmic techniques of search and destroy and so on. It's basically a single image that's captured and then responded to the device. When the device receives that signal, it sends out another beacon. So if it moves, it would be tracked and powered at the new location. The other thing is that the beacon itself is also an ID of the device, which enables the transmitter to know which device it's powering. In the bottom left, you can see that there's a person standing between the 2 devices, and basically they're blocking the line of sight. In that case, only the non-line of sight paths are available. They reach the transmitter, and the transmitter instantly, I'm talking instantly, like 1 microsecond later, sends the power back to the device. regardless of the line of sight availability. And you can see here, we're doing power at a distance. We're doing the selection of which device we're powering. We're doing motion because the beacon is repeated 100 times or more per second to ensure that it's always powered. Non-line of sight happens organically, and the safety is an organic feature in our system. We do not actually actively work to make the system safe. So you can see from here that we're addressing all of those with the Quota technology, and this enables us to power devices from the a few watts region to 100 milliwatts at the extremities. And the 100 milliwatts is a ton of power to power many devices in the environment. So we have taken this technology and built a whole stack of control and management and even web services to enable the management of the transmitters, so you can connect them and connect every receiver and able to communicate also at the same time with those receivers. So we create this reference design kit that we work with our partners, give them all the technology they need, access to the technology and licensing of the IP to enable them to build this into their devices. This includes engineering, training, and support for their work. Currently, we are engaged with several engagements that are active, with some of them have been piloted and tested successfully and moving into deployments in the coming months and years. So, people ask how far is wireless power is happening. You can hear from this panel that wireless power is here and it's here to stay. And wireless power is not an option for humanity. If we're going to, bring the number of IoT, which is a necessity for our data economy, we're going to need all those devices. So this is essential from delivering all the capabilities for hospitals, factories, retail stores, and infrastructure, logistics. That's even not reaching the home. And consumer electronics are going to be, taking advantage of this, as we always do as consumers, after the technology is proven in the field in other industries. But so what OSI has done is what we've been able to bring some of the largest and tier one manufacturers in their domain to the fold and work with them in bringing wireless power to the store. So with Walmart, we have multiple deployments that are happening at different parts of the company. Foxconn is maybe enough said. Galance is a Chinese company that builds most of the microwave ovens in the world, about 40% of them. Saint-Gobain, building infrastructure. Again, the building infrastructure is a huge thing for the economy. Toyota's work with us is to ensure that wireless power is in the automotive, but also in the rest of the Toyota business, which is in smart buildings and smart cities. And we work with SES and Magitag on the electronic shelf labels and bring that to the market. So OSI is really positioned in a place that can really have the biggest influence on the industry. And we see that the wireless power market is mature, and we see that now is the time for really the big adoption, as we have worked on the regulatory parts and the other aspects of this. And I'd like to be able to also address many of the questions that we have on this session. Thank you, Dinesh, for organizing this session for us.
Thank you, Nowaj, and thank you very much, Hatim. You were right on the spot. 10 minutes means 10 minutes, and I think you did a very good job there. But just quick messages. I'm sure there are questions there, and I can see the questions also pouring in. I'll come back to the questions in a minute. But I'd like to point about living a battery-less environment. I think that will be a need of an hour, and I think wireless power can only make it happen. So yes, like you say, we have this big opportunity in front of us, with everybody can try to prove that. And I also like the idea about wireless power equal to Wi-Fi. So yes, again, I surely have a question on that as to how we can see wireless power on the go. So we'll come back to that on that. And before I move to Ori, the second last speaker before me, I would have actually reminded the audiences to send the questions, but I don't think I may have to do that because I can already see not many questions on the screen here. So please start putting in your questions during the presentation, panel discussions, and Q&A sessions. Some of them we will try to answer there itself with the text messages, or otherwise we'll pick up and answer them live as well. So please keep sending your questions. And in case we miss your questions, we'll come back to you by email as well. So yes, thank you very much. And before taking more time, Ori, here you are.
let's begin. So I'll tell you a story about YCharge, but I think the story is basically about an industry. In the next 10 minutes, it's not really a pitch, so probably feel free to ask any questions and send it to the panel. We're here to answer. Hopefully it's not going to be bored, because we didn't came here to be bored, and I promise I'll tell you at least something new, which is always good. At the end, hopefully I'll make you smile. That's a WAWT cause, and say thanks to everyone. So let's begin. We know battery power limits usage. Whether it's IoT sensor, industrial sensors, iPhones, or electric vehicles, it limits how much time these devices can be used, and that's a pain for all of us. For every person that is being bored, I think 30 devices go online. It's going to be a nightmare to charge them all. What we not all of us know is that battery power also limits compute. Since manufacturers are trying to get you to a point that that batteries would not run out too fast, they also limit computes. That's one example. I'll give you one example. If you have a security camera at home placed on your porch, and that is you placed it there in order to protect a porch pirate that would steal your Amazon package. Most of the time, this camera is in sleep mode, and by the time it wakes up, because it has to preserve power, you only get to see the back of the teeth. So that's another problem when you don't have wireless power. Wireless power is actually a solution for both. It delivers endless battery life, and also in terms of battery power, it allows 100 times more power than batteries, so it can allow smarter devices. At YCharge, at our performance envelope of the technology, we started with mobile and are focusing with IoT devices. The fact that you can charge a device doesn't mean it's it's a low-hanging fruit in terms of commercialization. And I would not get to that now, but in terms of performance envelope, yes, even cars can be charged wirelessly, and it even makes economical sense in a way. But that's a topic for a different webinar. In terms of the application space, I think all the companies have spoken about it, and I'd like to present it once more. If you look at this graph, there is the high power regime, where high power means a lot of devices. Low power means small and lower power devices. You'd like to be on the high power side, even though the low power side offers a great potential as well. In terms of range, there is the short range, which means not really autonomous. You can charge devices wirelessly with proximity charging, but you don't get the user experience of it simply happens. So the place where we all want to be as an industry, and we said it already before, it's not that one size fits it all, but if we can get to high power and long distance, there's a lot of devices that we can power and we as people can enjoy. So why did it took, and that's the part that I think is relevant for all of us. Why did it take so long to develop those distance wireless power solutions? Because it turns out that you need, in order to get to do wireless power and to reach this regime, you need power, you need range, you need small components that can actually fit inside consumer electronic devices or industrial devices, and you need safety. And getting all of this together is extremely, extremely difficult, but as all the companies here are showing, it's not impossible, and it has been done. And why is it so challenging? And I promised you that I'll teach you at least, get you to know at least one thing that is new. And I think Niraj said it earlier. In order to stream Wi-Fi or to stream a video for a smartphone, you only need a nanowatt. Okay, a nanowatt is a watt divided by a billion. But in order to charge a smartphone, you need 1 watt, you need 10 watt. That's a billion or 10 billion times more power. Okay, so that's the challenge that we as an industry were facing. It's not that Wi-Fi signal is as strong as needed to charge devices. Okay, let's see the magic. It's a short video, 20 seconds, but at least you'll get to see what's happening. So this is an example of seeing wireless power in action. These devices, these 6 trains, are running wirelessly without batteries. Each device consumes roughly 1 watt, and that's it. You can replace every device here with, you can think of every device. It can be a smartphone, it can be a smartwatch, it can be an industrial sensor. It could be the fact that these devices are powered over the air in this example from this device here, 4 meters. That's what wireless power is all about. Now, just a second. Oh, at CES 2020, White Charge finally reached a commercial solution and publicly demonstrated with 7 different partners at CES, charging devices from 10 meters range. And for us at least, and I think for the industry, it was a big, we felt that things are going to go live. But then we were hit by COVID, and at least on our side, it caused a delay of roughly 1 year in our plan, but it didn't stop us. Earlier this year, we shared this we shared this dashboard, which indicates wireless power is really alive. What you see here is watt hour delivered worldwide, and it's basically saying, same as your electricity company monitors watt hour delivered, we started monitoring watt hour that delivered over the air, and I think that signals wireless power is alive, it's kicking, and it's spreading. We're clear. I saw a lot of questions about safety. So like everyone else, it's designed for safety, and we're cleared for commerce worldwide with the FDA, FCC, IEC annual approvals. A bit about White Charge. We're geeks, we're technologies from Israeli top defense technology unit. We're doing high-end technology for a living for the last 25 years. We already founded 2 successful startups in the past. One did fiber to the home, the other one was software as a service. One reached 80% market dominance, one reached 500 million users in less than 3 years. And we're here on White Charge on a mission to provide mankind with a new capability. Almost last slide. So people think about charging phones, charging devices that we know. But what I think would be the hidden treasure of wireless power is actually enabling devices that we have never seen before. And this is an example. This video is a video that was created by Nissan, the car maker. They wanted to promote their self-parking car with this video. What happened was that this video got millions of views, and people started calling Nissan saying, we want the chairs. Nissan told them there are no chairs. It's a marketing video for the cars. But people said, we don't care. We want the chairs. So if you think of those chairs and what is missing between them being able to be here today, it's only about wireless power. And it's not that hard to power this, but that's a technical session. Last slide, and I'm done, is to say thank you, Dinesh, for hosting this. You did a great job bringing us all together, and I think we all are here to thank you for creating this wonderful event.
Thank you, Ori. Thank you. I like the last part as well, for sure. But more than that, I think more interesting was three, 4 points which I collected from here. Hatim talk about battery less environment, and you talk about no battery environment. So it's really good news coming to us from a development point of view that yes, we have a solution here. We have different technologies to address different use cases and different issues there. So that's one what I liked. I also know that you reiterated the point which Neeraj also mentioned that there's no one size that fits all. So that's another one. The third thing which I liked was, you also mentioned very briefly about, why did it take so much time to develop the technology? I know people would have got a slight big understanding of that, but we can discuss that more in detail. Not hopefully with this on this podium, but we can do arrange another call webinar for that. And last one is that you all create some approvals for commerce deployment and well. So yes, thank you very much. And before I move to my presentation, which will be the last presentation by the panelists, I would like to say that thank you for sending across the questions. They are coming in well. We'll keep answering some of them through the text messages. So some of them have been answered already while we are speaking. But if in case you miss it, we'll pick it up in our question hour sessions, or I will run that through in my panel session. If not, then if you miss out, then obviously we'll reach out to you by email. So don't worry, but still keep sending your questions. We really liking them. Yeah. So what I will do is I'll now take, if Kat allows me, I will take the podium. I will share my slide and present my stuff there as well. Perfect. Thank you very much. I realized that I did not get a chance to introduce myself. So yes, my name is Dinesh Kithany. I'm the founder and the chief analyst at Wired and Wireless Technology. Again, like I said, I work in this industry, been working in this for more than 5 years now in wireless power market. And this is my first webinar, which I'm doing, a thought leadership webinar. I'm proud to host this with all the key industry players participating in this webinar. Saying that there are quite a few other partners also who were not able to join because of the logistics issues. But yes, thank you very much for this. Before that, let me quickly show you my stuff here. Yeah, what I'll be quickly talking about, obviously, just a slide on my company, the landscape about the wireless power technology, more in detail about distance charging. I have a quiz for you guys, so please keep attention on what I say because I'll be asking you questions. There could be a prize for that, and I'll end the presentation to let you guys know how big is this market opportunity. Just a very quick slide on my company. It's like I said, it's called Wired and Wireless Technology. It's a strategic technology analysis and a consulting firm. We deliver research, insights, and strategy. Our subject matter experts operate as a trusted advisor and a strategic partners to our clients as well. We have more than 25 years experience, more than 10 years in technology sector. Our subject matter experts like myself and all are the most sought after industry analysts. We invite you to speak at key industry events, webinars, conferences, and all the stuff here. The focus of the company is three key industries: wireless power supplies market, and energy EV charging infrastructure market. Our solutions are we provide data, reports, insights. We have intelligence services to keep you tap on the market as well. We provide consultancy services, and we also have thought leadership services like the one which we are holding it now. Again, our vision is to be the most trustworthy and sought after analyst firm in the industry. Just coming back to the wireless power, yes, we cover the wireless power has in detail like nobody else. From a coverage point of view, we have around 30 applications that we cover. And the reason for covering 30 is not for the sake of covering 30 applications, which span from automotive, mobile, medical, industrial, retail, and all. But the reason to cover them because we are seeing traction in the market. We are seeing activity in the market. Once the application sees traction, we cover them in the analysis so that our partners are able to identify the opportunity, know when to exit, when to enter the market, and all the stuff there. So that's on the coverage on wireless power market. Now I'll straight down going into our insights on the wireless power market. On that, we have the technology landscape. As we know, the wireless power market continues to evolve with more technology solutions being available, catering to the wide range of applications like we saw some of them. Example, to start with, we know about the low frequency solutions, which is called the induction solutions. The most popular is the WPC's Chi and Key standard there. Within the low frequency solutions, from a technology perspective, we also have magnetic induction solutions, which is a loosely coupled technology. And this more popularly currently used for electric vehicles, so charging high power applications. But there's other applications as well holding down there. So that's all on the low frequency solutions. Then we also have the high frequency solutions being provided in the industry, where we have what Sanjay presented about air-fuel alliance, magnetic resonance, a loosely coupled technology, wherein we have industry standard. We also have proprietary solutions like other solutions as well. Within the high frequency, we also have NFC charging, a loosely coupled technology, 13.56 megahertz, like many may know that. NFC Forum is the industry body who's governing that standard, and again, a very focused applications there as well. And last but not the least, we have ultra high frequency solutions, which is why we have here distance wireless charging, where we have multiple solutions. We have RF based, IR based, ultrasound based. I'm understanding we also have a 5G based wireless power as well coming soon. And we have on that front, we currently have only Airfield Alliance looking after the RF standard, but I'm sure we have more to follow there. So that's basically on the industry landscape. Let's see how the market is being evolving. So what we saw in the last 2 or 3 years, market witness technology environments, we saw 2 new applications or solutions coming in the market or technology coming in. We have key standard, the small kitchen appliance standard introduced by WPC. We also had NFC charging getting launched publicly, officially getting launched in 2019. We also have some solutions from the RF players launched in the market as well. So that's what happened in the last 2 years' time, new standard there. We also saw many applications adopting wireless power, not only smartphones, not only electric toothbrushes, but a span of applications, laptops, I would say smart watches, hearing phones, public places, small battery powered devices, infrastructure. And some places the products have been launched in the market, been used in the market. Some are at the very development stages, at the early development stages. Some are at the launch stages as well, which obviously I cannot reveal there. But yes, the interest has really gone across wider applications. With wider applications adopting this technology, we have seen the power classes also evolving rapidly as well. We have low frequency, low power solutions. We have medium power solutions, high power solutions, and every technology I will see every column there. We have different technologies providing different level of powers there, catering to different applications there. Yes, there are good and bad points about having so many classes of power, but yes, as we all know, this is a very early stage of the market here. And also at the same time, like we saw, there's a big scope for wider applications here coming in. And there's a tremendous scope for wider adoption, like we say here now. So if you see here, more applications, new standards, all are coming. And this shows that how I would not say rapidly, but how aggressively the market is growing the wireless power from different perspectives. More focus I will do on ultra high frequency based solutions, which is the distance wireless charging, which is also called as uncoupled technology. If you see that technology, that segment of the market, distance wireless charging market, is also evolving on a continuous basis, where we have seen interest has been increasing. We have seen activities which have been increasing. There's work which people have presented here, which I'm sure would have been new to you guys, because there has been impression whether something is happening or not happening in the industry. But I'm sure you know now that yes, the work is happening at an aggressive level. So we have distance charging, which is, like I said, is uncoupled technology. We have different frequency bands being used across this. Again, there are many reasons why we have those frequencies. Again, we'll put the question back to the panel as well. At the moment, we have industry standard from Airfield Alliance for the RF technology. Saying so, we have other proprietary solutions as well. And again, within the distance charging, we have different power classes. We have near field, we have far field, we have medium field as well. Catering to different segments as well. Saying so, we have at the moment we only got 5 key players in the market participating in this event. But as you know, the market is already crowded. I have few examples on my slide here, which says that around 25 companies already playing a big role there. Each of them are playing in a different space. Some very high power, some very long distance as well. Long distance, high power, some at a low frequency levels. 2021 already witnessed some few new players entering this market, which shows that there is a scope, there is an opportunity out there, and we all have to tap it. There's a need also in the market. So that basically talks about distance wireless charging here. Very briefly, this slide talks about, if you see all the applications there, these are the applications which are adopting wireless power now or in the next 1 or 2 years' time, or next 2 or 3 years' time. And the ones which I've highlighted them in orange are some of the applications, which are currently the target applications, which would possibly be using the ultra low or very low power solutions, less than 5 watts, as I would define it, possibly using long distance wireless charging. So as you know, This is the current state of the market. This is where the activity is currently happening. We have toothbrushes, we have electric shavers, we have electric shelf labels, wireless earphones, smart watches, vehicle interiors, key fobs, IoT sensors like few of us has presented here. We have public places, we have defense solutions, hearing aids. So across industry sectors, we have wireless power being looked at for adoption, and not only at a near field, if I would say, not only as a coupled technology, but as an uncoupled distance charging technology. So this again talks about how rapidly the market is growing with regards to adoption of wireless power, distance wireless power, if I must say. And before I move on to the next slide, I will ask Kat to just put on a quiz for you guys. So please answer. Let me know, what do you know about how big the market opportunity is. After that, looking into the response, I will then showcase the real numbers based on our research that we have conducted. Here you are. So you have two quiz here, one below the other. Please please put in your questions. Let me see how much would you have guessed or understand the size of the market is currently there. I had two questions for you guys. How big is the opportunity for the total wireless power market in the next 2 or 3 years' time? And how big is the opportunity for distance wireless power market? So let's see what is the most popular answer. I hope everybody has answered that. Pat, can you show the results?
There you go, Dinesh. So the results should be up.
Perfect. Here are the results. Oh, interesting. Very good. So I would say around there's an equal split between the audiences here who are saying up to 500 million devices will be charged in the next 5 years with any technology. Someone saying 3.5, and some of them are saying 7.5. I'll come to that answer as well. Let me see what are the responses for. In fact, you all can guess yourself whether you're right or wrong from my following slides. So next question is about how big is the opportunity for the distance wireless charging in the next 10 years' time. 10% have said up to 100 million, 20% 200 million, 20% says 1 to 2 billion, and there are 35% who says 13 billion, more than 3 billion. Wow, that's good. So which looks like there's so much optimism in the market. There's so much confidence in the market that they're saying, yes, distance wireless charging will have more than 3 billion devices that will be charged over the next 10 years' time. Okay, let's see what the numbers say. I'll go to the next slide. Very quickly, I'll run through those numbers here. Being the research company, I'm obviously obliged to only show some results. Otherwise, you will not come and talk to me about my reports. Yeah, so if I may say, this is the total wireless power market. Based on the research conducted by Wireless Technology Research, basically my firm here, the total wireless power receivers and transmitters market in the next 5 years' time is expected to grow by 8 billion. So yes, we were close, but not that very close from your numbers. So what we say is that in the next 5 years' time, there will be 8 billion devices which will adopt wireless power. This includes all applications, all technologies, all frequencies, and all power classes. This is the state of wireless power market. This is, again, keeping in mind only the 30 applications that my company research has conducted there or covering within the scope. So that's how big the market is at the moment, how big the opportunity is. Coming to distance wireless power market, yes, based on our research, the market is expected to grow from 70 million in 2025 to 1.2 billion. So in the next 10 years' time, I think some of people are really right. There is around 3.25 billion units of devices that will be shipped in the next 10 years, which will possibly use distance wireless charging or use less than 5 watts of power using that. So as we can see, from the opportunity perspective, it's a big opportunity there. And we already have, like I showed in my previous slide, we have large number of technology players working to make this happen. So this is, again, based on the research that we conduct. It's not any number put in through, so we know how big the market is. So with this positive remark, I will try to conclude my presentation and say thank you very much to all of you. And before we run to the next session, maybe Kat has something to say.
Thank you so much, Dinesh. Thanks. So I think we have another poll for the audience. So there's 2 questions again. We'll keep this up for about 20 seconds. And if you could put your answers to the 2 questions in the next 20 seconds or so. It's just a very short poll, quick answer. So here are the results. Question number 1, when would you think wireless technology would attain a mainstream status? And I think the most popular answer here by far is 3 years. And then we've got the question number 2. What information do you need to make a purchase decision to integrate wireless power? And I think definitely a leading answer here is cost-benefit analysis. So I'll hand over to any panelists now, if you'd like to comment on any of those.
I think this was well expected, and obviously the cost and benefit analysis is what is critical. And I'm sure some of the panelists have already answered that question very briefly. I saw Ashin mentioning that, but over to Neeraj or anybody else who wants to answer that, please.
I think, I think this is the most important aspect, right? I think technology is one part of it, right? Any new technology starts in the realms of technology, but we need to really take into the cost benefit analysis. Why should somebody really adopt it? Unless we can answer that, technology will remain a technology.
Perfect. Anybody else?
Yeah, the main things that typically block a technology from availability is the access, and able to have multiple choices, and as well as having a defined and well available understanding of its safety, its applicability, regulatory, and so on. Now, most of the wireless power that has, I can tell you from experience that historically people are wondering whether it is possible at all. Today, the question isn't about possibility, but about its practical use. And as we have more deployments in the market happening, that enables the confidence to happen elsewhere to adopt. So we will see, as everything else, it will be adopted by a few players in certain niche markets, and then this will slowly bring up the explosion. I'm a very optimistic person, but I'm not. I don't think that the consumer situation is going to be the first, as typically they require very polished and complete technology that has been vetted elsewhere. And this is true of wireless, cellular, Wi-Fi, and every other technology we have has been adopted elsewhere before the consumer adopts it, when its cost is down, when it's fully available, and so on. So I see that there are niche applications that can get to the market, but in general, these are the adoptions that will help get the wireless power to the market. I hope this answers the question.
I guess, yes, I think we have a good idea about the cost benefit analysis. I also had the same questions here, but before, I know we only have 10 minutes and we have to do a panel session and also do some Q&A session. So what I'll do, we'll split that time, maybe just 5 minutes, 5 questions to the panel audiences here. So I'll open the panel here. I'll ask the question and any of you can pick this up. So my very first question is to any of you, if you can answer, is that what are the best methods for delivering power at distance? I know we may have a biased response from each of you, but any guidance, any kind of guidance or without any comparisons would really help the industry associates to take right decisions. So if anybody can pick up as to defining or helping us to understand which is the best method, that would be really great.
Sorry, what's the question? Yeah.
I'm saying the question is, what are the best methods for delivering power at a distance? Because we're seeing a range of technologies, range of solutions available in the market. And without being biased, I just would like to know your quick view on that, so that people listening to us say, oh yes, there is so many solutions, different solutions, which one is best for what?
There is no single answer to this question, in my opinion. There are every use has a certain acceptance. For example, if you have a large transmitter, that could be a no-no for some applications, and something that's very adoptable in others. Otherwise, the cost of deployment, the ease of use, the control aspects are also things that limit the certain applications.
Okay, I would really expect you guys to make your question very, very brief, because it's answered. Because anybody else want to answer that, or should I speak to the next? Okay, no,
I agree with Hatem, right? And one solution is not going to fit all applications. We will need different solutions, and that's going to start having a portfolio of choices.
Perfect. Ori, you want to say something very, very quick?
I agree with Hatem and Neeraj. What we found as relevant to us is devices that can endure very small receivers and require high power. But again, as Hatem said, In some places, you can have a small receiver, a large receiver, small. There is a combination of value proposition that can address every device individually.
Sure, perfect. Sanjay, you want to say something, or anybody raise their hand?
No, I think we're good. So let's move on to the next question. I think we're all violent agreement here.
Okay, fine. I would go to the next question again. It's again a general question on wireless power, which is basically wireless power, especially the distance wireless charging, is about power levels. It's about distance, and it's about the speed of charging. So how are we trying to balance all these three needs in this current situation where we have the technology which is still maturing over the time? How are we balancing power, distance, and speed? Very quick questions, only to one. Okay, I'll give Ori a chance now.
First of all, I think people are not used to wireless power. If you don't have wireless power, say you you wake up in the morning and you have to drink all the water for a day. So you have to drink everything at once. That's why when you're wired, it's important to have high power. But if you can get constant power during the day, you don't need the speed charging, which also ruins the batteries.
Perfect. Good analogy, Ori. Sanjay, anybody who has raised a question here? Okay, Ashish, you go.
Yeah, I mean, I think the big thing that a lot of our customers have been really focused on is reliability, quality, robustness. Because at the end of the day, it's all about is power. We want to make sure it's reliable, it's robust, and that's the first barrier to kind of push through, and that's what we've been working on quite a bit. Is reliable wireless power, power delivery.
Perfect. Sanjay, I have a question directly for you now from the industry body perspective. So what kind of regulatory approvals are required or needed to integrate, say, RF wireless power into potential devices? Very briefly.
Yeah, no, it's a great question. I think safety is a question that comes up, and certainly we know with any wireless technology, but with wireless power for sure. And I think there are two kinds of regulations that you have to think through. One is, and they're all both pertaining to safety, by the way. One is safety for living objects, right? So human beings, and how much power you can expose them to at what frequency that the regulatory bodies will say is in the acceptable limits. Then the second thing is safety for all of the other electronics around us. So what it means is the electromagnetic radiation that is coming out is below whatever the rules are for that particular frequency band that you're using. And we have to, as an industry, meet both to be able to bring our products to market.
Okay, perfect. Two quick questions for the panel now. The next one is this, again, very, very obvious questions, and we have to really relay our message very clearly. So is distance wireless power safe? What have been the concerns as people are saying that beaming power not being safe and secure? And how are we tackling this issue? Anybody? Two of us. I want two answers, two panelists to answer this question.
Definitely, this is one of the biggest issues that has hampered this technology from coming to market. As we have advanced in electronics and design, we're able to now more or less address this with capability. Although this also depends on the methodology. For example, the technology that we use at ASIA has an inherent capability of safety that enables us to pass regulatory. So that really is the algorithms being used are more advanced than before. That helps a lot.
Perfect. I will also let Ori answer that. But Ori, if you can add a flavor to that question, which is again coming from the audience as I'm reading it, it says, yes, obviously, how safe is that, and what power levels are safe to power at a distance?
Oh, the safety is actually inherent in the power, the amount of power you can emit. So if something is safe at one level, if you just multiply it by 10, may not be safe.
Perfect. Hatim, I'll let Ori answer that question. Yeah.
Every company in this panel is designing their devices to be safe. That's a question. That's an answer to all the Q&As. We're here on a safety-driven products. The regulator would not allow any of us, and none of us wants to design a product that is not safe. Regarding the power level, I can tell you what we already approved. We already approved a 3 or 4 watt transmitter at roughly this size of the receiver at 5 meter range. But that was only not because of a technology limit, but because of a product that was approved. We can go.
Perfect. Ori, sorry, I'm rushing you guys here. One
Sure.
last question, which again coming from the audience, which says that again, when you talk about so many frequencies available there, because everybody is using different frequencies, how do we cope up with that? Because again, the market is getting crowded before even getting started. So, any answers on what is the best frequency, or you think there will be different solutions used?
Yeah, well, that depends on the capability of focusing the energy. For systems that rely on more harvesting, active harvesting, the lower frequencies are more suitable for that because you can emit a little bit more, and even if it's not that focused, it's not a matter of safety. But higher frequency can achieve higher power gain and power delivery if there's a focusing capability, which requires large phased array antennas as well.
Okay, Neeraj, you want to say something? Last few seconds?
Yeah, I think we need to look into from a system perspective to not just focus on antenna and you have to factor in the efficiency of transmitter, receiver, semiconductor at those frequencies. We definitely believe 900 megahertz is a good choice.
Okay, perfect. That's fine. One last question to the panel here. Again, this is one of the questions which is coming from the audience as well. $1 million question. When are we going to see our mobile phones getting charged sufficiently by using a distance charging? Just say 1 year, 2 years, 3 years, or not at all?
I think 2 to 3 years. I think we'll see
perfect.
that.
Ori, you?
I think it was already said before me.
Quick.
The consumer brands will not be the first, even if you can address their pain. They want to see it like Wi-Fi, like Bluetooth, like near-field charging. They want to see it in another application before they embed it.
I completely agree with Ori. You're not going to see in consumer first. It has to go through industrial and other application.
So when is the mobile phone? My question. 5 years?
I think 3 to 5 years. It depends on how fast the other market adopts.
Perfect. Ashish, you?
I was going to say it's also the consumer behavior has to change, right? With RF distance charging, you're not going to see the fast charging. You really will have to go to snacking or kind of subliminal charging. And that will require a significant change in consumer behavior.
Okay, fine. Ashish, you have to say something? 30 seconds, less than 30 seconds, sorry.
Yeah, it's just really down to the plethora of transmitters down to lower power devices.
Yeah, okay, so fine. I think we have run with that. And thankfully, I was able to catch up with some of the audience questions as well. Again, there are so many questions. I'm so happy to see those questions, but sad that we are not able to answer many of those questions. Really, really sorry, but we will really attempt to send you responses, personal responses to each of you answering every question. So don't stop sending your question. Please send it to me or send it to me as well. My presentation will have my email address, which is dinesh.kithany@wawt.tech. So please send your questions. I'm sure I'll give you assurance that you'll get answers to each of them. Good or bad, you'll get the answers. So before I end and give a line of appreciation, we also had another poll which I cannot run. I would say 10 seconds. If anybody wants to say anything. There's a closing remark. Sanjay.
I was going to say, look, I think it was a great panel, and this is what makes me excited about the future of wireless power. It's great to see the energy, great to see the progress that all of our member companies are making together.
Perfect. Sanjay, sorry, Neeraj.
Yeah, I think first of all, thanks, Sanjay. We are part of Airfield Alliance for a long time. We believe the market opportunity is there. It's ready to ramp. The question is how fast the regulators and technology can provide those solutions.
Perfect. And Ashish.
Yeah, just give us an email. And my email is ashish@transify.com. We have products for sale, so buy it.
That's a good use of 10 seconds. Hatem.
Just being on this panel with all these other companies shows that wireless power is coming to the market as quicker than most people think.
Excellent message, Hatem. I think I really appreciated that. Ori, what do you say?
First, I'm happy to be here with all the other people and with this industry. And our contribution to the industry, I promised that you would see at least one consumer application this year and one commercial application this year.
Glad you answered that, because that was my question, which I couldn't ask. But yes, that's really good news. So with this, I would like to thank each and every of you for giving me this opportunity to host the Industry First Joint Industry webinar. I'm sure everybody liked it. You participants liked it. All the audience liked it. I'm sure the recording that will go out they will also be liked in the media and audiences there. And I'm sure we are going there with a positive message. Again, I'm the industry analyst. I'm not here to say good or bad. And I'm here to relay what is the reality of the market here. And yes, looks like we are positive. Looks like the companies have solutions, technology in the market, and that looks like the timing is also right. It's just like we have to handhold each other and get it happen and get it soon. And I think the title of my webinar answers it. Distance wireless charging is a reality, if I may say. Okay, so with that, I thank everybody, even Kat, for a wonderful organization of this. And really sorry to audiences if we have not answered your question. I can see many of them have not been answered, but please send us that email, send it to me, and I will share with each of the audiences there. And thank you very much for waiting 10 more extra minutes and seeing this insightful webinar. Thank you very, very much. Take care.